name is Adam Anderson. I am a professor and a scientist working out of California. I'm also the leader of Team Andersons, which consists of me and my entire family. Ever since my kids were little, I've taught them how to code. I've taught them robotics. My girls and I do a first Lego League robotics team. Since all my kids are underage, they're not officially on the team, but they will be someday. My oldest is getting his degree in computer science, and he will be joining my team as soon as he achieves that goal. I just really like the competitive atmosphere. To me, I was never good at sports, so I'm never going to the Super Bowl, but to me, these are the Super Bowl of the engineering and scientist community. The strategy we took really is to treat it like a video game, which it kind of is. And really, the test is just Pac-Man. Everywhere we haven't been, there's a little dot that we actually in our code we put a virtual dot onto the map, and our robots gobble them up. And if we are able to gobble up all the dots, that means we've been everywhere, and we should win. The robots that start out initially are the fastest, and they just go as deep as possible, right? That is their only goal, is just the trailblaze. Some of the slower robots, they take their time, they follow the walls, they drop their breadcrumbs to help other robots. They pick up spots that maybe the fast robots had missed. All the robots do communicate with each other, whether they're the flying UAVs or the ground drones. They do communicate. They share with each other everything that they've learned so far, so we don't lose time. These terrains are very large. A single robot can't really get through the entire place on its own. So our robots share paths they've taken, artifacts that they've discovered, obstacles that they've run into. We set up. If a robot runs into something it hadn't seen, it lets the entire team know that there's an obstacle there. When a robot finds an artifact, it adds it to its database, the location and which type of artifact it is, and every few seconds it'll share that with everybody. And then the idea being that since everybody's sharing everybody's knowledge of where the artifacts are, eventually they'll make it back to the base station. Surprisingly, I found that the artifacts are the easiest part of the competition. I don't know. I have a machine learning background. I've done all this object recognition. I've played with that for years now. And since there's a limited number of artifacts, it's easy for the robots to use their sensors to first detect an artifact, and then to localize on it, they just put it in the middle of their screen and drive towards it. What I found is we're pretty robust to the dynamic obstacles. So like I mentioned before, our robots share the paths that they've taken within the environment, right? Now, if a rock fall happens, it essentially cuts or severs the path that you've taken. So it's pretty easy to take that dynamic nature and then just route your path around it so that we still are sharing useful information. So one of the reasons I do these competitions is as an example for my kids. I have 8 of them, and I'm hoping that they'll all be scientists and engineers. And so I just try to show them that, even if you're by yourself working alone, you can still accomplish big things.